All right, so in energy efficient building construction, one of the things that happens is you want to build the structure very what's called tight. So that means that you've sealed as many of the cracks and air gaps and insulated the structure really well so that you don't have air infiltrating into the structure in a non-controlled manner. On most residential construction, you do not have a ventilation system in the building. What's assumed is that there's just going to be enough leakage in that house, and with the number of door opens and things like that, enough air is going to get into the house to provide air exchanges. That's in comparison to in your school building, which has a code required amount of air that has to get changed every hour. But in residential homes, that normally doesn't happen that way, at least not mechanical. It's called mechanical ventilation. But when you build a building really tightly and energy efficiently, you have a problem where the air becomes stale and you're not getting those air exchanges. So you have to add mechanical ventilation. Well, mechanical ventilation could be as simply as a fan where you're blowing air out and bringing air in. But that's not very efficient because you've conditioned that air, you've heated it or cooled it using your air conditioning and heating system, and then you're just ventilating that air out. So you can use an energy recovery ventilator, which is what this black box is, and what it basically does is it brings the exhaust air from the somewhere in the house. There's vents in there, return air vents, and it brings it across what basically is a heat exchanger. So the two flows of air don't actually mix and touch inside this box, but they pass close to each other in a way that they can trade BTUs. So you can imagine in the winter you've got hot air in the structure and cold air out, and you bring that hot air next to the cold air stream. And as we know in physics, that those BTUs want to rush to the lower energy density airstream, and so then it preheats basically that air, that fresh air coming into the structure, and then you basically recover some of those BTUs and that energy that you'd spent to heat the house, and the air that is coming in the house, instead of being 32 degrees, is 45 or 50 degrees, and you've both improved the comfort of the building and saved energy.